Hi folks, the purpose of this video is to introduce the concept of linear regression. First of all, I would like to say my understanding of linear regression is from applied AI course, and some of the images used in this slide are taken from the famous Coursera course by Andrew Ng. So the entire credit of the video goes to both of them. So now we take a very simplified case of crime prediction. We will assume there are only two variables in the input dataset, that is density and crime. We only have density and crime. We will use density to predict crime. It's a very simplified case. In real world, there will be many features which we will use to predict crime rate. So here crime rate is a dependent variable because that is a value that we are trying to predict, and density is an independent variable. So if you think about it, crime rate should increase when density increases. So we can write as when density increases, crime rate increases. So in linear regression, we will assume the relationship is linear. That is, the crime rate is directly proportional to density. So that means crime rate is directly proportional to density. That means crime rate is equal to a constant k into density. This k is called the proportionality constant. So the aim of linear regression is to find out the proportionality constant k. So on the right hand side you can see a plot. On the x-axis we have density, on the y-axis we have crime rate, and it's a scatter plot. In the dot represent the input dataset, the combination of density and crime rate, and here you can see a line, a best fit line that we found using linear regression. We are using a method called least square method, which we will come to later in the coming episode. Now the question is, how do we find out the best fit line, that is this line? So here you can note that we need to find out the slope of the line m and the y-intercept c. As you all know, the equation of a line is y is equal to mx plus c. Here k is m and c is the intercept term that we need to find. So here we have two constants that we need to find, m and c. So given m and c, we can calculate crime rate given density. Now we will see the basic flow of a machine learning problem. We have the input data set. We will split the input data set into two. One is training data and the second is test data. We will use training data to build the model. So we will feed the training data to a learning algorithm, which will output a function which is conventionally denoted by h. It is called hypothesis function. So the hypothesis function will take size of house in this case as input and the price of the house as output. In our case of crime prediction, the input is density and the output is crime rate. So the hypothesis function will map density to crime rate. So in the previous slide we have seen that we need to find out two constants m and c in the linear equation y is equal to mx plus c. We will rewrite that equation. We will rewrite that equation like this: h is equal to theta 0 plus theta 1 x. It's the same equation as y is equal to mx plus c. This is the y-intercept c, and this is the slope of the line m. So now we will introduce the concept of loss function. Let's say we have density on the x-axis and we have crime rate on the y-axis, and we have some data, it is spread across, and we will find the best fit line. So the best fit line is an approximation of the actual data. You can see that. So for this point there is an error. For every point you can see there is some error. Sorry for the drawing, but I think you got the idea. So this error you can calculate by doing this h of x minus y, where y is the actual value, that means the dots you can see in the scatter plot, and h of x is the predicted value. So it can be positive or negative, because if the dot is above the line, it is positive, otherwise it is negative. So we will take the square of it, because we need to make everything positive. So if you take the sum of this function from I is equal to 1 to m, we will get the sum of the loss, and we will take the average of it, so that we can get the average loss, and this thing we will define as j of theta 0, theta 1. This is the cost function that we have, and we will try to minimize this cost function so that we will get the best fit line. So j is the cost function, and this is the equation, and here we will add a constant 2, so that later when we take the gradient of this term, the exponent 2 will be cancelled off by this constant. Okay, now we will see how we will find out the minimum value of the loss function. Here you can see the plot on the left hand side. There is a random line. It is not the best fit line. So you can see that it is being adjusted when the algorithm is run to find out the best fit line. That means the line having the least loss. How do we find out the line? That is the question. So we use an algorithm known as gradient descent. It's an iterative algorithm. Gradient descent. We will take the cost function, we will take the derivative of cost function, and we will multiply by a constant called learning rate, and we will subtract theta. We will subtract that value from theta to find the next value. We will repeatedly do this to find the best theta. So we will repeat this till convergence. Theta j is equal to theta j minus alpha dou by dou theta j of j. This is what we do, and here j can be 0 and 1 in this case, because we have theta 0 and theta 1. When you have multiple variables, it can be up to n. J can be from 0 to n. So we will see how gradient descent works in one dimension. We will take density on the x-axis and crime rate on the y-axis, and the cost function looks something like this. So it's a ball-shaped curve. So we will take a random value. Let's say it's here, and using the iterative algorithm, we will take small steps to reach the minimum point. This is the point having the minimum loss. So on the right hand side you can see that the curve has multiple minimum points. So the point of convergence depends upon where you initialize. As you can see here, there are many points of convergence here, here, here. So thankfully in linear regression, the curve is not this complex. It's a convex function. That means it has only one global optima. So whichever weight you start with, whichever random value you start with, uh, the gradient descent algorithm in case of linear regression will converge to the global optima. Here you can see a gradient descent in 2 dimensions because we have both theta 0 and theta 1. It's a 2D plane, you can see. It's a mountain like shape. So the point you initialize, the point you converge depends on the point you initialize. As you can see, it is converging to the blue point here, but had we initialized somewhere here, somewhere here, then it might have converged to this point, this local optima. On the right hand side, you can see the 2D plot of linear regression. It's a cost function. So this plot is a convex function. It's a ball-shaped function having only one global optima. So this height represents the cost at this point. This at this point. There is only one global minima. There are no multiple minimas in case of linear regression. So gradient descent will always work. So in real world case, there will be multiple features, not just one. We have assumed density is the only variable which can predict crime rate. But in practice, it can be multiple variables like maybe unemployment rate, or maybe per capita income, or overall development of the region, or it can be anything. You can see in the database there are so many columns, there are so many features which we can use for crime prediction. We will see how we will select which feature to select and what weightage to give. So my point is, here we use an extended equation for the hypothesis function h of x is equal to theta 0 plus theta 1 x. This is the function that we have already used because we assumed there is only one variable x. So since there are multiple features, we will use the extended equation theta 2 x2 plus etc. up to theta n xn, because we have n features. So we will try to minimize this cost function and find the values of theta 0, theta 1, theta 2, theta 3, etc. up to theta n, so that given a set of value x1, x2, x3, x4, x5, etc. up to xn, you can multiply with the constants and find out the value of hx, which is the crime rate. I will quickly tell you the structure of the plot so that it will be easy for you to go through. So, first of all, we will see, we are doing a stepwise explanation of linear regression. So the first step that we do is data loading. That is just to load the data from a CSV file. It can be any input. And the second step is to do data analysis. This is to analyze the data and to find if there is any problem with the data. Then we will do EDA, which is exploratory data analysis, to visualize the correlations between features. There are two ways of doing EDA. One is by using just one variable to predict the target feature, that is a crime rate here. So when you use one variable, it is called univariate analysis, and when you use two variables, it is called bivariate analysis. The next step is to do data cleaning. That is to clean the data uh, based on data analysis and EDA. We can remove irrelevant and incomplete informations. We can remove missing data. We can remove some errors if there is any, which we will find out in the which we found out in the previous step. That is the EDA and data analysis. This is a very important step without which we can't get a clean model. We can get a good accuracy. So next step is to build the model. Here we develop a good linear model to predict crime rate. Then we do the training using the training dataset as in the input. After we are done with training, we have the model to evaluate. So we will evaluate the prediction performance using test data. Then we will draw some conclusions as to how good the model is, and we will suggest some improvements also. As a closing thought, we will see how this model can be used in real world, and what other advanced machine learning techniques we can use for crime prediction, because linear model is the simplest model that we have. There are many advanced techniques, and this is how the blog is structured. So happy reading. Thanks a lot.